All right, class. In this video, we're covering pages 5 and 6 in your in your lecture handout for section 4.1, exponential functions. And so on page 5, example 6, you're given the graph of an exponential function the graph passes through the point 2, 9 in the coordinate plane, right? 2 is the x coordinate, 9 is the y coordinate. And so the form of the exponential function, you know, is f of x equals a to the x. And so we got to figure out what exponential function has this graph. And so we got to figure out what the value of a is for this graph of this function. So again, the point 2, 9, right? The x coordinate is 2, the y coordinate is 9. And so in the function f of x equals a to the x, right? Remember, y values and function values are the same. So we can replace the f of x here with y and then plug in 9 for y and 2 for x, because the graph of the function, right, passes through the point 2, 9. And so this equation has to satisfy that point 2, 9. So we have 9 is equal to a squared, and now we got to solve for a. So in solving for a, we take the square root of both sides, and we get the square root of 9 is equal to square root of a squared. Now earlier in the semester, when we were solving equations for x using the square root method, right? You remember the quadratic formula, you'd have the plus and minus in front of the square root of 9. Well, we don't have the minus in front of the square root of 9, because the value of a in our exponential function, the value of a can only be positive. It can't be a negative number. So we just take the positive square root of both sides. And square root of 9 is 3, and so we have a is equal to 3. So in our function up here, or function form up here, f of x equals a to the x, we replace a with 3, and our function is f of x is equal to 3 to the x. So this function up above here, the graph of this function here, right, it comes from f of x equals 3 to the x. On page 6 of your lecture handout, you're like, we're going to do the same thing for another exponential function. We're given a graph of an exponential function that passes through the point minus 1, 1/5 in the coordinate plane. Minus 1 is the x coordinate, 1/5 is the y coordinate. And again, right, the form of our the form of our function is f of x equals a to the x. Remember, y values and function values are the same, so we replace f of x with y, and then we put in 1/5 in for y and minus 1 in for x, and we have 1/5 is equal to a to the minus 1 power. So now we got to solve for a. Well, a to the minus 1 is the same as 1 over a to the first power, right? Remember, the minus sign in the exponent means reciprocal. So a to the minus 1 is the same as 1 over a to the first power. And so we have 1/5 is equal to 1 over a, and now we just got to solve for a. So there's multiple ways of doing this. One way is, you multiply both sides by 5, and you multiply both sides by a, and you end up with a is equal to 5. Another way is you can cross multiply. 1 times a is a, 5 times 1 is 5, and you end up with a is equal to 5. Right? So there's a couple of different ways you can show that the solution to this equation is a is equal to 5. So up here in f of x equals a to the x, we replace the a with 5, and we have f of x is equal to 5 to the x. So the function that this graph up here came from is f of x is equal to 5 to the x power. This guy right here.